Yes. All right, we'll come back to the graphs here in a second, but I want to talk a little bit about the test. I'm supposed to have grades in tomorrow, which I'll put grades in tomorrow, but I can always go back and edit those. So you'll still have the retake option for this. I do need to shorten that time period down a little bit though, so you won't have a full week like you usually do, but you'll have till the end of this week. Okay, so through Friday this week, I'll allow you to do a retake on this, and then I can go back and edit your grade, because this is really the last grade of the first 9 weeks. Okay, so if you're interested in doing retakes, you can start working on your corrections on another sheet, and then we'll set up the time to do it. But I got to make the deadline Friday this week. Okay, just a few from the test I want to talk about. Overall, the front side was pretty good. One kind of small thing on part C for number 2, the pattern you knew you were multiplying by half over and over again. So when you looked at the 225th term, what I was really looking for you to see there is, well, if I keep taking a half and taking a half and taking a half, we're going to get closer to 0. Yeah, so really I was just looking for that you're getting closer to 0. Some of you put what you got if you plugged in 225, which I took that. But really it's just the idea that you're going to get closer to 0. Then on number 4, probably the common error there. I really have 3 things that I'm multiplying in that problem. Well, if I gave you this problem, I said take 3 times 5 times 8. What would you do first? If I said find the answer to that, what would you probably do first? Okay, maybe you pair up the first 2. Do I have to pair up the first 2? No, but I need to pair up 2 of them, right? Get that answer, and then multiply it by the third one. I wouldn't take 3 times 5 and then take 3 times 8, okay? And that's what some of you did here. You took 2 times this one and 2 times that one. But really, you just want to pair up 2 at a time. So if I were doing it, I'd probably do these 2 first, get my answer, and then multiply that by 2. Okay, so that was a common error on that one. Back on the first page was pretty good. Didn't run into consistent problems probably till number 10. Number 10 was one of those where we had standard form for the equation. And we wanted to get it into graphic form. So we talked about pulling, in this case, the 2 out of the first 2 terms. Then we started completing the square. So we took half of the -4. Well, when I do that, 2 squared is really 4. I turn around and multiply that by 2. So now I'm up to 8. But I wanted to be at 15, so I had to add 7. So that would have been graphic form, which means our vertex would have been at the point 27. So a little bit of confusion on that one. The bonus. So a lot of good work on the bonus. A lot of extra work on the bonus that you didn't necessarily have to do. The key to this was they didn't ask how much 1 wiggle was, how much 1 waggle was, and how much 1 wuggle was. They asked for what's the total of 1 of each. So a lot of you did a system of equations and did a lot of algebra, which was great, but it was some extra work. Because if we think about it, if I put them all together, I had 1 wiggle for the first situation, I had 2 wiggles on the second situation, and I had 3 on the third situation. So 1, 2, and 3 tells me I have 6 of those. I'm just going to call it A. Then I had the waggles. Well, I had 2, and then 3, and then 1. So I had 6 of those as well. The wuggles, I had 3, then and I had 1, and then I had 2. So I had 6 of those. And when I put all those together, I had a total cost of the $150 plus the dollar, so $250 plus another $1.40, so $3.90. So that's the cost of 6 of each. They want to know the cost of 1 of each. So if I divided all these by 6, that means I'd have to divide this by 6. So the cost of this one plus that one plus that one is 656. So that was the fastest way of getting there. So I wasn't talking about each one, they wanted the total cost for all 3. So 2 extra points were possible on that one. So a lot of paper used on that one, which is good. You guys tried it out. All right, so again, Friday would be the deadline for retakes. If you're going to do retakes, if you need help with the corrections, let me know and I'll help you out with those. All right, the graphs. Here's what I want you to do. We now have some new groups with our new seating locations. Essentially, most of us are in groups of 4, some of us are in groups of 3. But where our 4 desks are together, those are going to be our groups. So this is the group, this is the group, and so on. The desks are set up a little bit better now because I got 6 rows instead of 5, so it's a little bit easier to kind of figure out who your partner is or within your group. So let's go ahead and move into those groups if you would, please. It'll just be you 2 today. You'll have it heard. But go ahead and move into your groups. First of all, introduce yourself to your group members. You don't know everybody. And then secondly, compare what you got for your equations of your graphs.
Just sit around me and I turn around. Yeah.
Give them in the middle, maybe.
What do you think?
First one, I got y equals 1 over x plus 2.
Second one?
Yeah, x squared minus 5.
Yes.
Minus 3
Yep.
2x minus 5 minus 2.
I got y equals 2x minus 4.
Oh, you can.
How are you guys?
Because we can get the oh. I got 3x minus 6.
Yep.
I got x plus 2.
Yeah.
X plus 3 squared minus 2.
Yep.
X minus 3 cubed, squared plus 6. And x plus 3 minus 2.
Yep.
Yay!
I don't know, it's up to you. I did that, the bonus, I did that. I divided it by 6.
Then you divide it all.
No, I did that. The very beginning I did that. And I'm like, oh gosh, that's not right. And then I was trying to figure out all this stuff. I went from here, and I don't know.
Wait, Mr. White, so would the retake go into the first quarter or this quarter?
Yeah, do the first
I wonder if I could get my grade on it.
Oh, no, see, what I was doing,
I got my
I
other grade.
was up 2010, 30, I did the right.
Say you got, best case would be 100 on that. Say you did the retake of 100 on it. That would give you 96. Average the 2 together. So I'd have to look at it and see how much that would change things.
No, 170.
Okay, hopefully the parabolas were fairly straightforward when you did those.
I was
So B, you should have had that for your equation.
That's really good.
Now, like I said, you didn't have to worry about a stretching or compression part on these. So you're worried about just the shift. So B, you should have had that for your equation, x squared minus 5. And then G and H. On H, you did have to think about the fact it was flipped over, so we had to throw that negative out in front. But hopefully we're feeling pretty good about those. Probably the y equals x cubed is the one that's closest to those type of problems as far as picking out your locator point. So the first one that was an x cubed was C. So let's see, group in the back, what did you get for an equation on C?
On C, y equals x minus 3.
Right, the only shift we made there was 3 to the right. All right, F was another cubic. Let's see, this group there, you guys get that equation on F?
Y equals x plus 2 cubed plus 3.
Good, this time we went 2 to the left and up 3. So x plus 2 cubed and then plus 3. Then we had one more cubic. The last one, with this group here for the last one.
Y equals x plus 3 cubed minus 6.
All right, so hopefully those weren't too bad. The tricky ones sometimes are the ones that are hyperbolas and exponentials. So let's look at those two examples. Part A was a hyperbola. Remember with the hyperbola, what we're going to look at is where does the vertical asymptote meet the horizontal asymptote? Well, those two meet over here at -2, 0. So really the only shift, question?
On I, shouldn't it be y equals x plus 3 cubed minus 2?
Is only 2 or 3? I think it's over 3. Yeah, I think it's over 3. Wasn't mine. But going back to this, those two intersect at the point -2, 0. So the only shift that took place is we went 2 to the left. So in my equation, I'm going to show that by saying x plus 2 in the denominator. Plus, remember this vertical asymptote is when it makes it undefined. And we know -2 plus 2 would be 0, and that's undefined in the denominator. So that would be your equation for that one. For D, we're looking for where the horizontal asymptote is, and then we also look at where the takeoff point is. Well, the horizontal asymptote's been shifted down 3 units. So we know that we're going to have -3 at the end. The takeoff point, well, ordinarily the takeoff point is at 0, 1. We already know it's been moved down 3 units. This one wasn't moved left or right at all. So I'm still going to have 2 to the x power. So that one should have been 2 to the x minus 3. Now, had that been, say, over here, say it would have been like right here instead. Well, that would have been shifted over 1 to the right. And so that would have changed things. That would have said, okay, 2, since it moved to the right, x minus 1 would be my exponent, and then it's still down 3. That would have been the change had it been moved over there. But for this one, we didn't move it anywhere. Well, then I threw in that line, which may seem out of place. We usually don't think about shifting lines. You probably thought about the slope-intercept form for the line. What was our equation if you did it in slope-intercept form? Group in the middle here. Do you guys get that equation for the line?
Y equals 3x minus 6.
Okay, so most of you probably wrote it in that form, wrote it in the slope-intercept form. But you could also kind of think about this as far as shifting. If I had to come up with a parent equation for a line, what would you think the parent equation for a line might be? What's the simplest equation I could come up with? y equals x. All right, and a y equals x has a y-intercept at what point? 0, 0, the origin. So what we might think about with a line is, okay, well, when we did equations of parabolas, we wrote it like this. When we did cubics, we wrote it like this. Well, why can't I write the equation of a line like this? So let's think about it if I did write it in that form. Well, h and k would really be any point that I have on that line. Because when I move the line around, I move every point around. So let's just pick out a random point that's on my line here. And I could use any point I wanted to. Let's say I use this one right here. So that's at 1, 2, 3, 1, 2, 3. So I could say this. I could say y equals a times x minus 3 plus 3. What do you think a is in terms of the line? What would affect how much it's going up? The slope. So the slope, we already know the slope is 3. So I could have said, okay, well, this is really 3 because that's the slope. Like this. And that might be a different way to write it. What would I get if I multiplied that out? 3x minus 9 plus 3. Or in other words, we get 3x minus 6, which is what you wrote when you wrote it in slope-intercept form. So really, you could think about that line. You'd still have to find the slope, but really I could use any point I wanted to. And that's actually referred to as point slope form when we write it like this, where you have to know the slope, but you can use any point on the line in order to find that equation. And usually point slope form is actually easier than slope intercept form, but just another way to think about that line. Well, hopefully we're feeling pretty good about moving stuff around as far as our graphs are concerned. What we're going to look at today is what happens when we make another slight change to our functions. What's that going to give us? All right, so we've done all these different types of graphs. So let's think about what we know already. So if I started with some function, f of x, and I said I'm going to do f of x and then plus k. Well, no matter what function I have there, what would adding or subtracting a certain value do to that graph? Move it up or down. So it's going to translate it, move it up or down. And that happens no matter what kind of function we have. Then we also looked at a situation where I had a negative out in front of my function. Well, what happened when I threw a negative out in front of my function? What are we going to do there? Mia, what's that going to do to it? Okay, so it's going to flip it, or I'm going to use a different word. I'm going to say reflect it. If I'm going to reflect it, I have to reflect over something. Well, what were we reflecting over? Like when we did our parabolas on there. Alex? What line? Which axis?
Y-axis.
Other one. Because we went from here to there. So it's going to be over the x-axis. And that's why when we had a parabola, it went from opening up to opening down. We made changes where we said we have f of x minus h inside the parentheses. Well, what did that do to our graph? How did that move it around? Claire?
Shift it left or right.
Yeah, that one's going to move it left or right. And then lastly, we had the situation where we had a times our function. And what did that a value do out in front?
Compressed or stretched it.
Good, compressed or stretched it. And so we did all those different things with a number of different functions. Here's what we're going to look at today. What if I were to take a function and I looked at the opposite of x and made that our input? How is that going to affect our graph, and what sort of situation is that going to create? So here's what you're going to do. You're going to look at some different functions. You're going to look at 6 different ones. You're going to look at y equals x squared, y equals x cubed, y equals the square root of x, y equals 1 over x, y equals the absolute value of x, and y equals 2 to the x power. So you're going to use all of these different functions. What you're going to do first of all, and this is on the back of your page there, it says for each of those parent equations, you're going to substitute in the opposite of x or the x that was originally there. And then it says algebraically simplify the result. Well, here's what I mean by that. If I started with this function, f of x is equal to x squared, we're now going to look at what happens if I were to put in the opposite value of our original. Or in other words, we're now going to do this. Well, if I were to do that, if I were to take the opposite of my original value and square it, what am I going to end up with? What's negative x if I turn around and square it? Logan, what did you say? Yeah, we're getting a positive x squared, right? Which in this case was back to where I started. And that's why when we made our parabolas, everything on the positive side looked like everything on the negative side. So that one, it didn't really change anything. However, if I were to look at x cubed, and I change that to the opposite, what kind of answer do I get if I take a negative value and cube it? If I did negative x times negative x times negative x, I get negative x cubed. And now we went from I used to have a positive x cubed to now I have the opposite of that. So sometimes things will change, sometimes they may stay the same. Well, you're going to do that for each of these different parent graphs. Once you plugged in the opposite x, you're now going to graph those on the same set of axes. In other words, I'm going to put this original and then this graph on the same set of axes. Now that example is no big deal because it's going to be the exact same thing. But then I'll turn around and set up a new set of axes where I'll look at this graph and this graph and put that on there. Now that will look different. And you're going to sketch those. That's what you're going to do on number 6. So number 6, I should see 6 different sets of axes, and then you'll have your graphs on each one. Okay, so you're not gonna put all 12 on one, you're gonna break them into the 6 different paragraphs. Make sense? Alright, so see what you can come up with there. Plugging in the opposite of X now, but then making sketches for the original versus the opposite of X.
So why do you go square root of negative x, which is the gamma, like you never said?
Except, be careful, and I understand what you're saying there. So if you do the square root of a negative X, you're right. But really what we're gonna be saying is the square root of the opposite of X. So what kind of numbers would work if I did the opposite of that number and then did the square? So that means I could put in negative numbers for X, but then I'm gonna do the opposite of that negative number, which makes it positive, and then I can do the square. So it looks like you're right. You're right, it does look like it's gonna be undefined, but you can actually get the graph up.
So,
Once you get your new equations with the opposite of X, it's okay to plug in your calculator and see what those graphs look like. And you're gonna be sketching. You don't have the exact graph, just do sketching. Make sure you're doing a comparison of the numbers.
Those things, x squared, x cubed, what did it have?
We're looking to, it'd be one.
So this one was, there. Then it's negative.
I'm pretty sure.
Then it's a negative. The negative thing, the negative, power, the negative is negative. Got it? Yes, sir. So then the other, then it's behind. Equals 1 over x, and the that equals 1 over negative. You know what I'm saying?
Now we're gonna do the next one, so the square root of X. And I'll put the square
And
root
then
of
you put them all together.
Good question.
Yes,
Looks like
no,
it's right. Square root
they're all
of
going to be right between 24.
However, the opposite.
So it's supposed to be 6 graphs, and you put the camera,
No,
and,
you're still doing the
graph
square root
on
of
one
X.
axis.
You're doing the opposite of whatever X is.
So this is now,
Yeah.
this y equals the absolute value of x, and then you flip it, the absolute value always positive number, but it's the distance from 0. So when you flip it, when you're just getting a negative number,
Those are the ones that work, right? That means when you make your graph, the
because
way it
absolute
works,
value
X is
doesn't matter which direction, so
that, you get to
it's
the positive.
y equals negative absolute value of 2 is going to be right?
Well, it's.
Yep, I'll put you in here. Here's what they just started on. For all of these paragraphs here, substitute in the opposite of X. You can simplify it. And you're gonna sketch the original and then that new graph on the same set of axes. So you'll have 6 set of axes there.
Then you're right, so you're supposed to be the same.
Okay.
But if I put it outside, it's gonna go like that.
Mr. White,
Yes.
so on the y equals absolute value of x, do you want the negative on the outside of the bars or inside?
It'll start out on the inside. But what happens when I do this for, or the absolute value?
Well, my thought process was because this, well, the answer to this will always be positive.
Correct.
Since it's distance. So I was thinking that, well, yeah, it's positive, it's the same number as x, and just negative, flip it, or just be negative x.
Except if I did, and everything you said is great, but if I do put the sign on this and then do the absolute value, I'm still gonna get.
And then it goes.
In other words, if I said the absolute value is 3, we know that's 3. If I said the absolute value is negative 3, so actually it turns out to have the same output.
What if it's a positive?
Now, if on the outside, that'd be different, you're right, we'd make it the opposite side. Yeah, you're right, if you were on the outside.
There we go, that's what I'm looking for. Rachel, you need any help? No, I don't think so. Okay.
As you start making your graphs, look and see if there's anything you can notice about the graph.
My shoulders no longer hurt. School had one.
I think that's what I
Wait.
put an extra here.
If you put the negative on the inside, it's just gonna be like that. But the outside on the outside.
But that's not, do we put the negative on the outside of the outside?
It's the input that's changing, so we're gonna keep it on the inside. So
Okay,
here's essentially what you're asking, if I put in, say, 3 here,
so
then the actual value. Is my result gonna be the same or different than if I put negative 3 in the actual value?
with
So in this
this
case, what's gonna happen?
negative part,
Are you gonna be a practice?
it would be a reflection. So how do you show it?
Oh, yeah.
Mr. White? Sorry, stupid, I forgot the question.
Questions are good, that's right.
So, I figured out that this would be just a reflection, but then how do you write that on the grade?
Definitely.
One thing you could do if you wanted to is take care of the negative exponent, which means I have to move into the denominator. Keep in mind, it's not the principal exponent, it's exponent is negative, which means I'm going to move the entire 2 to the x to the denominator. So one's on the top, and then it's 2 to the x.
Oh,
So maybe one way to write it.
alright.
Is the negative, like, is it below?
Yeah, pretty much. They're all just reflections. Except for.
Rachel, you're figuring this out quick.
Except for this,
If we go back to those, what are you gonna do before you know the
Negative, if we're good at math, X squared. I would say like.
Give you a 3. This is more negative, you're gonna plus.
And how about challenge?
so I wouldn't even, I just draw one from.
I can just want it. The only problem is I get her for
So you're changing the value on the inside versus what you did just x, just negative x. Saying, because that would be like saying, what's the absolute value of 3?
I'm definitely more of a social studies girl.
You're right, sometimes if you stick to the paragraph.
For teaching that semester. Well, I'm pretty sure it's covered. Because yeah, I have her for psychology. She teaches both, as well as the rest of
I just know what I put down.
Probably shouldn't be getting this high.
I
That's
kind of.
basically,
I'm giving it a high.
That's fine. Oh,
yeah, but it looks like it's gravel. I don't know why I did this.
So it's.
No, with the, number 7.
No, the left, the left. No? I have a stick.
Yeah, no. It looks like it should.
You definitely had a stick.
Please don't put on your shoulder because I can't on the back. And I just slammed it. Yeah, I slammed it. 3 hours. Or 30 minutes. And it's so good, I slammed it. Oh, that's always fun. Yeah.
This one be on this side.
Surprisingly, I have never ever broken this bone. Like, everyone looks at me and they're like, oh, you're proud, you must have broken 2 million bones. Never broken this
That would
bone.
mean I'm getting negative answers.
I broke a chunk off of it.
Negative. And that's going back from
Which is why I'm so lucky that I'm right-handed. My right hand I was like 3 or 4 times. I had to. Are you okay? Yeah. Mrs. Brown, do you know how to perform CPR?
What?
Do you know how to perform CPR? Like, have you been certified? I have. You have to practice with CPR done.
No, no, yeah.
I,
You really think it's going to give you 100?
and, yeah.
I swear I could have been third grade on that. I feel like I was third grade. Like, my mom is still mad at me. And my dad is. Yes. The only thing, the big thing that she took off was the Lakers, but like, how did I miss that? Organization. Took 6 points off for that. Let's go ask her, but I don't want to get that.
Okay, try to get through as many as you can here in the next 3 minutes.
It was probably because I was so sorry.
No, I got a B plus 2 and I was so mad. Are you serious?
Surprisingly enough, I got 193 out of 200, and I was like, what?
Yeah, just move the.
Where on
Yeah.
One, or no, it was 179.
Yes, 179 because I also.
Yeah. 179. If you were hitting your paper, I did all the things that I did to it. That's the most confident I've ever felt about
Oh,
essay.
me too.
She just shot me.
Same, I feel you.
I'm awful at writing essays, but like that one,
I was so proud of myself. I was like, this is gonna be amazing. Guess what? It wasn't. I will. I'm gonna go up there and be like, you crushed my dream.
got me to go first friend. Yes, friend, I wanted to be an author until I graded my essay. I'm now going to go into the field of science. I hope you're proud of me. I hope you can still speak at night. I took out all my other ones. I was so happy with it.
A little bit.
How do you put this in the calculator?
I don't know. I'll try to figure that out.
I don't think you can put it in mine.
Master,
Or a new person. How do you put the absolute value?
You got one of them, but.
I love my.
All right, I put all the original parent graphs up here. Let's see how they compare to when we put in the opposite of x. When you did that for x squared, we already said that that was going to simplify to the exact same thing. So that means that my graphs turned out to be the exact same thing. All right, so both of those have the exact same. Were there any other graphs that were like that, where the original and the one where you put the opposite of x in, it gave you the exact same graph?
I don't think so.
Yeah, there's one other one. Which one on? Absolute value. So there were two where both of them were the same. Because it doesn't matter whether I take the absolute value of a positive or a negative, I'm going to get a positive answer either way. Well, we said that when we did this one, it changed a little bit. And you should have found out that your new graph looked like this. Well, we'll come back to that one here in a second and see what happened with that one. There was a lot of discussion in groups on this one, which was good, because you put in the opposite of x, and I heard a lot of groups say, well, I can't do the square root of a negative, which is true, but this isn't really saying negative x, it's saying the opposite of whatever x is. So you're right, if I keep putting in these values here, that's not going to work, because these values are positive. If I were to put them in and do the opposite, now they're negative, that doesn't work. However, what kind of numbers can I put in there and then do the opposite and then do the square root?
You can put a negative number.
Right. That's why your graph ended up over here, because all the negative x's worked because I did the opposite of those. So that's why your graph was on the other side. Your graph for 1 over x, when you put in a negative x, should have looked like this. That should have been your new graph for that one. What about 2 to the x power? If I made that now 2 to the negative x. Well, you might think about that negative exponent could be positive if I moved it down to the denominator. So what's really happening is I'm taking 1 and I'm dividing it by 2 over and over and over again. And what do we say that meant we were going to get close to? 0. So as we go along, we started out larger, but then we got smaller and got closer and closer to 0. So it should have looked like that. So each of these graphs, something happened. To get from the original graph to the graph that I just made in red, what would I say happened when I did this situation? There was still reflection, good. Reflection over, Logan?
The wire.
Y-axis this time. So we're gonna reflect over the y-axis. So when we did the opposite of the output here, it reflected over the x-axis. When I do the opposite of the input, however, it reflects over the y-axis. Well, we're going to use that result to make a decision about naming our functions. We're going to try to fit our functions into one of three categories. We're going to try to fit our functions into either an even function, an odd function, or we're going to say it's neither one. Here's how we're going to make that decision. If I did the reflection over the y-axis and I ended up with the exact same graph that I had before, that's considered an even function. So which ones did we say would be even here if that's the case? Which ones did I reflect over the y-axis and I ended up with the exact same graph? What was one of them? X squared. What was the other one? Absolute value of x. So from these 6 that are up here, the 2 that would be considered even would be y equals x squared and y equals the absolute value of x. And that's because when I reflected it, I got the same graph. So if you're asked, is this an even function? One way you can check that is you can graph the original one. You can graph the one where we put in the opposite of x, and you can see if you ended up with the exact same graph or not when you reflect it over y equals x, or over the x-axis, y-axis. All right, odd functions. Well, odd functions will be the ones where when I reflect it over the y-axis, I end up with a graph that is actually also reflected over the x-axis. Because when I have an odd function, this happened. F of negative x equaled the opposite of f of x. So what's an example up here that once I reflected over the y-axis, it's actually an example of reflecting over the x-axis as well. What's one example, Bryn? X cubed. Because when I reflected over the y-axis, that's the same as reflecting over the x-axis. So that was one of them. What's the other one, I think? Say it again. Right, this hyperbola here. Because when I reflected over the y-axis, that was the same as reflecting over the x-axis. So x cubed and 1 over x are both examples of odd functions. Let me go back to the even one for a second. Another way of thinking about this is if I were to do f of negative x, that's the same thing of getting f of x. They didn't change. That's why it was the same graph. Well, if it's not even or it's not odd, we consider that just to be a neither situation. And that happened when we did the square root because I reflected over the y-axis, but it wasn't the exact same graph. It wasn't on top of itself. Plus, I didn't reflect it over the x-axis. Same deal here with the exponential. I reflected over the y-axis, but I didn't get the exact same graph, and it wasn't reflected over the x-axis. So those other two would be considered neither. So part of what we'll start doing now is start classifying functions. So are we looking at an even function? Are we looking at an odd function? Or do they not fit into either category?
For y equals negative absolute value of x, would that be a neither?
The negative absolute value of x?
Yeah, when
So like if you started with this originally, that one?
Yeah.
Let's see, if I put in, that would actually be an even one as well, because if I put in 3, for instance, and then I put in negative 3, I'm going to end up with the same output eventually. So that would be an even one. It would just be this one flipped over. We're gonna look at another way on down the line that we can check for even and odd as well, but for right now, this is how we're gonna attack it. We're gonna look at what happens once I reflect it over the y-axis, what's the result that we end up with. All right, I'm gonna give you guys the rest of the time here to start working on Thursday's assignment. We're starting a new quarter today. Like I said, the test was really our last grade for the first 9 weeks. So we kind of got a fresh start here. As we enter this new quarter, something I want us to do a better job of as a whole, most of you did a pretty good job, but as a whole, making sure we're staying up on assignments, make sure we're doing assignments completely, okay, not just writing down answers, things of that sort. But mainly making sure the things we're staying on top of those assignments, because as we start adding more and more stuff on here, you know, it's going to get more difficult if you have to practice those concepts. So stay up on your homework, make sure you're completing homework completely. You got 20 minutes to get going on that today.
But when you're moving this x-axis, you probably if there's an x-axis, not a y-axis. So,
Well, keep in mind though, you're right, the circle.
because if it's only the y-axis.
Right, but keep in mind when you do this, the original, the very quote unquote original graph will be this. Now we're going to do it this. So what I mean by that is, we started with, when we were doing the parent graph.
I did. I went to there like 5
This was our
times.
parent graph, that's the one we started with.
Automatically
Then we
just
did
put it
this.
Yeah. I missed it.
Compare. Now you're saying, okay, I want to start with this. And I want to do this to it. I'm going to compare those two back. If I go to say 3 here, what would I get for an output? If I say, okay, change that 3 to a -3 here, what would be my output? If I put the absolute value of -3 would be, and out to that would be max, right?
I like that.
Oh, I see. So it actually,
Because I was comparing this one to this one.
yeah, so now if you're gonna think about this, that would be the starting. And we would go back. Okay, I'm gonna start with this, and let's see if that one is moving on. Versus, we already know what's happening with this, now this is a brand new graph. It'd be like, say I gave you this. Say, okay, is that even or odd or neither? Check it.
Claire,
What happened?
you don't want to drive? I
I don't
don't mind.
know, like
3
graph
months.
it, which would be the best way, graph this one, graph that one, and see what they reflect on themselves. I can also think about the reverse side.
And then you're thinking about going there.
Go back to my example 3. If I gave you a 3 here, what would I get for an outcome?
Just ignore me.
If I said X equals 3 here, what would I get for an outcome? The actual value is that. Now we're not. So this, graph. Yes, easy. And that's where we'll start heading for.
We definitely should get it.
That's 20 minutes, a lot of time. If you don't need it, I won't give it to you.
Like, I'm just saying, we started, I think we shared, it's been a long time.
Yeah.
Yes, please. I feel like,
Yeah.
That's the biggest thing that happened.
You like yelled at you every time they didn't turn on the light.
I was in
Dorothy.
What's up?
You're very excited. Peter has a lot of energy. We basically make up the whole class. Everyone else is just like hiding in the corner.
Well, I
Like,
definitely
oh
don't.
I'm not nervous for it. I think because my partner wasn't there. He kind of bailed on me. About it.